Hello everyone, this is Aditya Sharma, and in this lecture we are going to solve one of the past papers of IBDP MAA higher level exam, and it's paper 1 which we are going to discuss. And this paper recently came, it's May 2025, last year paper. Okay, so let's just start solving this question paper. Let me connect. So yeah, as you can see, MAA HL, May 2025, and paper 1, which we are going to solve. All right, so question number 1 we have here. Okay, consider the function. This is a cubic function. X belongs to all real. The graph of y is equal to f of x has a local minimum at point P comma Q. P is always positive. So what they want the value of P and the value of Q. Okay. So the concept for the local minimum point is, what is it, the concept? Yes, the concept is that the first derivative should be 0. And if you are getting multiple points and you are not sure that which point is minimum, then you will go for the double derivative, put the value and check for what it is coming. The double derivative, it is coming positive. So we will calculate the first derivative. So 4/3 times 3x square minus 16. 3 gets cancelled. So 4x square minus 16. This is the first derivative. So we will write for local minimum of f of x of y is equals to f of x. F prime of x supposed to be 0 to find the stationary points. So 4x square minus 16 is equals to 0. Divided by 4 both the sides, so x square minus 4 is equals to 0. That means x is equals to plus minus 2. This is what we are getting so far. Here we are definitely getting two different points, x is equal to plus 2 and x is equal to minus 2. But if you pay attention, in the question they have mentioned the local minimum point is p comma q, but p is positive. So that means we are only getting 1 point. So we will simply say because p has to be positive, therefore x is equals to 2, or x coordinate is 2. Okay, we can directly write therefore p is equal to 2. This is the x coordinate you are getting. Once we have got the x coordinate, what do? We substitute this value in the original function. Remember, in the original function, not in the derivative or the gradient function. Correct? So you will get, you will get the y coordinate. Fine. So we will go. So we will know f of 2 will be, or we can simply write first q is equal to f of p. P is equal to f of 2. And f of 2 will be what? 4/3 times 2 cube minus 16 times 2. Absolutely. So how much we are getting here? 4 times 8, which is 8 4 are 32. 16 2 are also 32. So 32, if I take common, 1 by 3 minus 1. So minus 2 by 3 minus 64 by 3. 6 and 4 collectively give you 10. So it cannot be simply divided by 3. So q will be simply minus 64 divided by 3. So our point P comma Q is coming minus 64, 2 comma minus 64 by 3. Simple. Okay. Okay. Now let's move to the question number 2. Question number 2 of paper 1 says what? Bob invests 1,000 dinar in an account which pays a nominal annual interest rate 4% and compounded quarterly. Compounded quarterly, not annually. Be very careful here. The amount of money in the account after one complete year can be written in this particular form. K is rational number. Okay. Write down the value of K. Fair enough. So if you remember here, because it is K represent, okay, let me write. So future value formula is, expression for future value is present value times 1 plus r by 100 whole power n. This is the formula. Over here, the rate of interest has been compounded yearly, and n is the number of years. Compounding periods in number of years. But here, explicitly, they have said that it is compounded quarterly. So whenever it is compounded, so it was the rate of interest will be what? Divided by the same factor. And the number of compounding period will also gets multiplied. Correct? So here this is 4. So what it will become? R by, we can say 4 divided by n times 4. Why we are multiplying and dividing by 4? Because they has been compounded quarterly. So rate will be decreased by 4 times, 1/4, and the compounding periods will be 4 times of the original time period. This is the simple logic what we have. So let's go for it. So if we do it, so present value 1000, 1 plus r is how much? 4. 4 divided by 4 is 1 divided by 100. N is number of years after 1 year. Okay, they have said here after 1 complete year. So n is equal to 1. So 1 times 4 is 4. So we are getting this. So now if you compare this expression with this, so we can write on comparing. Pairing the above expression. Expression with the given one. We are getting k is equals to 1 by 100. 1 by 100, 0.01, whatever you wish to write, it's totally fine. Clear? Okay. A part done. Expand and simplify 1 plus x whole raised power 4. Okay, this is basically binomial expansion if you see what they are asking. Fine. So we will do 1 plus x whole power 4. It starts with 1. 1 raised power 4 will remain simply 1. Then 4 choose 1. It looks like a plus b whole power n. So a to the power n minus 1, 4 choose, like if it is 4, so 4 choose 1, a to the power n minus 1 times b. Something like that. So it doesn't matter, 1 raised power 3 will still remain 1. If you want to write 1, it is totally fine. Times x. 4 choose 2, 1 square, x square. 4 choose 3, 1 times x cube plus 4 choose 4, x to the power 4. If someone is listening this very first time and they say, what is this 4 choose 1, 4 choose 2? These are binomial coefficients. In some of the textbook, they are written as 4 choose n, 4 choose 2, n choose 1, n choose 2. Otherwise, they could be written as in this form. It is just the same thing. Clear? Nothing special. This will 1, 4 choose 1 is simply 4. So 4x. 4 choose 2. So 4 into 3, 12. 12 divided by 2 is 6. So plus 6x square. Okay, how am I calculating this first? I'm just using this formula. N choose r is equal to n factorial divided by r factorial times n minus r factorial. I'm just using simply this formula, nothing else. Okay. Okay, 4 choose 2 done. 4 choose 3 will still be 4. So 4x cube. And 4 choose 4 is 1. So simply x to the power 4. This is the expression we are getting here. Clear? So B part is also done. Now what they are saying, hence or otherwise find the amount of money in the account after 1 complete year, which is the future value, which we started over here. Okay, giving your answer corrects to nearest dinar. So if we look at the future value expression, okay, so future value is basically 1000 times 1 plus 1 by 100 whole power 4. So it could be written as 1 plus 0.1, 0.01 whole power 4. So basically 1000 times 1.01 whole power 4. Now, it's fine. We can work with this. Why they are saying this question below this? Because we have just written 1 plus x whole power 4 expression. So we can utilize this expression to write this and then multiply it by 1000. Simple. Okay. Fine. So let's go. What they said corrects to, giving your answer corrects to nearest than. Fine. So if we do this, it will be 1000. I'm opening this with this reference. So it will be 1. 4 times x, that means 4 times 0.01 plus 6 times 0.01 square plus 4 times 0.01 cube plus 0.01 whole power 4. Nothing special as we have done here. We are doing so far. Okay, remember these two brackets are covering everything. So be very careful with the brackets. So what do we have? 1000. Okay, if we do this start, so 0.04, 0.0001, and this will be multiplied with 6. So we will be getting 0.0006. Okay. I do not think we need to go for this part and this part. We can avoid it because they are not contributing anything significantly. Because this will be 0.1, 2, 3, 4, 5, and then 6. And then when it got multiplied with 4, it will be only this. So we can avoid it because what they want is giving your answer correct to nearest. We can totally ignore it. So we can just write dot dot dot. What do we are having? So 1000 and we are having 1.0406 when it gets multiplied. So what we are getting? 1040.6. Nearest dinar they said 1041 we can go. Clear? Like this. Those things will not add any contribution. That's why I just said dot 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 and we will eliminate it. Fair? So this is the question number 2. Okay, so now we have a question number 3. And this is saying find the area completely enclosed by the curves e to the power x and minus times e to the power x and these lines. Okay, so let's first draw the diagram to understand. Okay. So this is y is equal to e to the power x graph. Minus has been multiplied to original function to get this function. So it is basically just the reflection in the x-axis. So it is just like this. Simple. Okay. So y is equal to e to the power minus x. Lines x is equal to minus 1. So we can consider, okay, this is the line x is equal to minus 1. And this is the line x is equal to 1. Okay, because of my irregular drawing, it is looking like this is more closer to x-axis and this is further. But in actuality, they both will be the same. Okay, yeah. Now there are two ways to deal with this situation. Okay. First is you calculate the area upper function, integral of upper function minus integral of the lower function from x is equal to -1. Simple way is that. Okay, that is one way to do it. If you don't want to do it, what you can do, you can calculate the area of this part. Simple. And you multiply it by 2. Why? Because this and this are just the reflection of each other. So this part should be equal to, this entire part will be equal to this entire region. So your choice, which way you want to do, both are completely fine approaches. Okay. So I will say, because y is equal to e to the power x and y is equals to e minus e to the power x are reflection of each other in the x-axis. Therefore, total area, I will simply write 2 times of integral of e to the power x dx. Simply, I'm just considering the upper function. Okay. From where to where? Again, simply from -1 to 1. Simple. Now we do the integral. So 2 times integral of e to the power x is e to the power x itself. -1 to 1. 2 times e to the power 1, which is e itself, minus e to the power -1. If you want to leave your answer like this, you can leave it like this. It's totally fine. If you want to write it like this, it is totally fine. If you want to further solve, 2 times e square minus 1 will divide by e, or you can write it 2 by e times e square minus 1. This is still totally fine. You can write your answer in any of these 3 forms. It's perfect. But remember, at the end, always write square unit, because we calculated area. So unit needs to be mentioned. Simple. Okay, fine. All right. Question number 3 is done. Okay, question number 4. Probability. Consider events A and B such that P of A prime is equal to P of A union B, and that's equal to 3 by 4. Conditional probability of B by A is given. A intersection B, they are asking. Fine. So if we will use the information provided to us, so probability of A prime will be simply, okay, 3 by 4 it is given. Probability of A prime is simply 1 minus probability of A. So what we are getting, that 1 minus probability of A is equals to 3 by 4. So probability of A will be 1 minus 3 by 4. So 1 by 4. So we got this. This probability of union is also 3 by 4. So let's do it. We are doing A part first. So probability of A union B, that is also given 3 by 4. Probability of A union B is what? Probability of A plus probability of B minus probability of A intersection B. Simple. Okay, probability of B, well, we do not have this, we do not have this. So let's approach it later. Let's use this information. Probability of B by A. So this is 2 by 3 is given. The expression for probability of B by A is probability of B intersection A or A intersection B divided by probability of A. Simple. So we will use this is equal to this. So probability of B intersection A divided by probability of A is equals to 2 by 3. Probability of A, we have got it. So probability of B intersection A is 2 by 3 times probability of A, which is 1 by 4. So 2 by 3 times 1 by 4. So if we solve this, it is coming 2 cancel 1 by 6. B intersection A. Yes. Now we have probability of A, which can be put here. Probability of A intersection B, we can put it here. And probability of A union B here. So yes, we can calculate probability of B. Okay, so first part is done. Probability of A intersection B or B intersection A has been calculated. Here, part B will start. So part B is this information. Let's start. So 3 by 4. Probability of A 1 by 4 plus probability of B minus 1 by 6. Okay. If I take this expression here, so 3 by 4 minus 1 by 4, which will be 2 by 4. 2 by 4 is nothing but just 1 by 2. So 3 by 4 minus 1 by 4 and plus 1 by 6 is equals to probability of B. So what we are getting here is 1 by 2 plus 1 by 6. So if we see this, how much it will be? So 3 plus 1, 4 by 6. If we take the LCM, this will be 3 times, this will be 1 time. So 3 plus 1, 4 by 6. 4 by 6 is 2 by 3. So probability of B is coming simply 2 by 3. We have got. But what they are actually asking in B part, show that events A and B are independent. The condition for any two events to be independent, if we look at it, is that they do not have any effect on each other. That means probability of A intersection B, that means probability of happening of A and B both. It is probability of happening of A and probability of happening of B. Simple. Okay, so we have now probability of A, we have probability of B, and we have probability of A intersection B. So we just need to check that this product, whether this product is equal to this or not. Simple. So now we will go. Now, probability of A times probability of B. So probability of A 1 by 4 times 2 by 3. And if we simplify this, 2 cancel. 2 cancel for 2 times, so 1 by 6, yes. And 1 by 6 is the value of probability of A intersection B or B intersection B. So yes, we will say, therefore, probability of A times probability of B is equals to probability of A intersection B. Sorry, not therefore, because. Therefore, events A and B are independent. Simple. Clear? Yeah. So this discussion looks really gorgeous. Okay. Consider a sequence of 10 rectangular picture frames. 10 rectangular picture frames. Okay, F1 to F10. Fine. So 10 rectangular picture frames are there. F1 has width and height this rectangular. Okay. The width and height of picture frame Fn can be each increased by 50% to generate the width and height of the next picture frame. 50% increase, that means total how much it will become? It will become 150%. Because what you have, for example, whatever you have, let's call it X, and you increase 50% of it. So plus 50% of X. So what happens? This X, I can write it multiply by 1, simple. And 1 itself is how much? 100%. X is how much of itself? 100%. So 100% of X plus 50% of X. So how much is total? 150% of X. You can look it like this way. Okay, so much more easier to understand. Fine. So show that the area of picture frames is like this. Since length and width increase in length and width increase shows a geometric pattern. Therefore, Fn will be what? First of all, area of we will go frame Fn is equal to area of frame F1 times common ratio raised power n minus 1. Simple. I'm just writing un is equals to u1 times r raised power n minus 1. That's it, nothing else. Okay. So area of the frame 1 will be 4 times 5. Now the common ratio will be how much? So common ratio is how much has been increased. How much there is an increase. So we will say R is interesting. R will be how much? A2 by A1. If you do not like to write in the form of words, it's totally fine. You can write A2 by A1. So what you got? You got 20 here. What you have here? A2 will be what? 150% of the width. So 150% of length. So how much was the length? Oh, sorry, width and height, whatever it is. Sorry. So 4 times 150% of 5. Initial area is still 20. Whole power n minus 1. So if you solve this, 150%, that means 150 divided by 100. So 3 by 2. So 3 by 2 times 4 times 3 by 2 times of 5 divided by 20 whole power n minus 1. You can see 5 4s are 20 cancelled out. 3 by 2 times 3 by 2. So what you are getting? 9 by 4 whole power n minus 1. Your choice. Like as I was doing before, I was calculating the area 1, then I used to calculate area 2, then I used to calculate the common ratio from that. Then I write the expression. Or you write the expression directly and then you solve it hands-on. Your choice completely how the way you want to solve it. Okay. Just represent everything clearly, explain examiner everything clearly. Okay. First part done. Hence, find the mean area of the 10 picture frames. Okay. Giving your answer in this particular form. Okay, mean area we need to calculate. So that means we need to calculate the average. And average, if you remember, the expression is sum of all the observation divided by number of observations. So it will be sum of all the areas divided by how many number of areas we are getting. How many picture frames are there? 10. Simple. Clear? So let's just go. So second part. Mean area is actually sigma of sum of all the areas initiating 1 to 10 divided by 10. This is as simple as it is. Clear? There's no rocket science in this as well. Fine. So if we go, so 1 by 10. First area 1 is 20. We have this expression, so we will go according to this expression. Second area will be 20 times 9 by 4. Third area will be 20 times 9 by 4 square. And all the way to 8, 10. N should be 10. So when n is 10, 9 by 4, 10 minus 1, which is 9. Is this Clear or not? Simple. Okay. Now we will add it up. This is the geometric sequence with the common ratio 9/4 and the first term 20. What is the formula to calculate the sum of the geometric sequence of Sn? Expression is Sn is equal to A times or U1, whatever you write. Like if you write Sn is equal to U1 times R raised power n minus 1 divided by R minus 1. Some of you, I understand, some of you might have gone through U1 times 1 minus R raised power n divided by 1 minus R formula. Both the formulas are correct. You can use any of the formula. The recommendation is you can use this formula when R is greater than 1 and this formula when R is less than 1. For simplicity, no thumb rule is there. Okay, so your choice. So I'm going to use the first formula because 9/4 is more than 1. So 1/10 outside. U1, which is 20. R, which is 9/4 raised power n. N is 10 minus 1 whole divided by R minus 1. So 9/4 minus 1. This is the expression we are getting so far. 10 cancels 20 directly 2 times. So I'm getting 2. And over here in the denominator of like here, we are getting 9/4 minus 1. So 9 minus 4, which is 5. So 4 will jump into the numerator, divide by 5. And here we are getting 9/4 whole power 10 minus 1. So we are getting 8/5 times 9/4 whole power 10 minus 1. This is the expression we are getting for the mean area. You can check P times 9/4, P whole times of 9/4 whole power alpha minus 1. P is a positive rational number. We got it. A is positive integer. We did got that. Okay. Sorry, it is A, not alpha. Yeah, my bad. Okay. Now what they are saying? Find the... Oh. Wait, what? Wait. Find, okay, median area. Okay, sorry. I was hypnotized at what they are asking the same question. So this is the median area of the 10 picture frames, giving your answer in the form of this. Okay, so median is what? The middlemost term. It's not 10, like the average we used to calculate like the mean way. It is one of the central tendency. Fine. So B part, median will be what? Because over here n is equal to 10. It is even. That means not one single area will be the median area. It will be the average of the middle two. So median area will be what? If you do directly, you can do directly. If you want to use formula, you can use formula. So median area will be what? Median, when even number of terms are there, then the formula for median is n by second term or second observation plus n by second plus 1th observation whole divided by 2, which means average of the middle two values. This is the formula. I hope you have gone through the similar concept. Just the terminology might be different. If you do want to do directly, go ahead, no problem at all. Okay. So 10 by second observation or second area plus 10 by second plus 1 area will divide by 2. So if we go through this, so it is basically saying 1/2 fifth area plus sixth area. So A5 and A6, okay? So if we go for A5, how we will go to A5? We have this expression. Clear? Okay. Let's call fine of 20 times. So when n is equal to 5, it will be 9/4, 5 minus 1, which is 4. N is equal to 6, 9 by 4, 6 minus 1, which is 5. That's what we are. We cannot leave it like this here because we need to write this in the form of this. So what we are going to do? We can take something common. So for example, what we can take common from here? We can take 20, we can even take 9 by 4 whole power 4 common. So this entire term can be taken common. Now what is left inside? This is 1. 20 has been taken, 5 minus 4, 1. So only 9 by 4. Only 1 power of 9 by 4 is left. 2 cancel 20 10 times. So 10 times 9 by 4 whole power 4. 1 plus 9 power of 9 by 4. 9 plus 4 is 13 by 4. 30, okay, 10 and 4 can be simplified by 2. So 5 by 2. Okay, now 13 5 ja how much? 65 if I'm not wrong. So 65 by 2 times 9 by 4 whole power 4. This will be the final answer. Again, square unit, and I'm not sure, yeah, square unit. Clear? So, I mean, this was a really beautiful question, I must say. Yeah, so this is the way to utilize. Okay, question number 7. Let's deal with this. Consider the complex number 3 to the power iota minus 1. Okay, this is interesting. Write the integer 3 in the power in the form Euler form they are asking. Iota minus 1. So first of all, I can write 3 to the power iota divide by 3 because minus 1, so 1 by 3. Why did I do this? Is, for example, any complex number when you are writing, either it is z is equal to a plus iota b, r time cos theta plus iota sin theta, or the Euler form r times e to the power iota theta. R needs to be there. Here there was no part directly given to us. It was hidden. So I am just writing in this particular form. So if I write now, so it will be written as 1 by 3 times c to the power iota. Clear? That's why I wrote it in this particular form. Now, this is exactly why they are saying that write this 3 in the form of e to the power alpha. So we can write this z is equal to r times e to the power iota theta. Proper Euler form. Okay, this is the actually approach. Fine. So A part, if I go 3 can be written as 3 to the power 1. 3 to the power 1 can be written as natural log of E. Why I'm doing this? Because I want to convert it in this particular form e to the power alpha. So from where I got the inspiration. And now I remember from the property that the base of the exponent and the argument of the logarithm can be interchanged. So I'm going to utilize this property. So it will be e to the power natural log of 3. Simple. Okay. So now I got part A, and part B, what they are saying, Hans giving your answer in this particular form. What? Cos or cis? Okay, we will see. Okay, real part they are asking. No? Fine, fine, fine. Okay. So B part, if I write, go back to Z, 1 by 3 as a real part, or we can say at a modulus of the complex number will remain intact. So 1 upon 3. This 3 will be changed. This 3 will be written like this. So e to the power natural log of 3 power iota. Power of power will be multiplied. So 1/3 of e to the power iota natural log of 3. This is our complex number. Simple. if we write it or if we convert it into the trigonometric form or the polar form, whatever you call it. So 1 by 3 cos theta, theta is natural log of 3. Imaginary part will be iota sine theta, which is natural log. So what they are saying, we need to write down real part of z. So if we focus here, real part of z is simply the part which is free from the iota sign. So this part. So it will be 1/3 of cos theta of natural log of 3. Yes. Now what they are saying? Real part of 1 upon z. Okay. 1 upon z, if we calculate, 1 upon z is simply z raised power minus 1. So I'm going to apply the minus 1 form. So 1/3 1 by 3 whole power minus 1 cos of natural log of 3 plus iota sine natural log of 3 whole power minus 1. Simple. This will be simply 3. The power will come inside. So what we are getting, cos of negative of theta. So negative of natural log of 3 plus iota sine. Or we simply say, if we know that cos theta plus iota sine theta whole power minus 1 is simply cos theta minus iota sine theta. You can write directly if you know. If you don't, no problem. You can write the expression that cos theta plus iota sine theta whole power minus 1 is cos of minus theta plus iota sine of minus theta. And then it will become cos theta minus iota sine theta. Your choice. So let's write it directly. So it will be cos of natural log of 3 minus iota sine of natural log of 3. So real part of 1 upon z. Okay, do we have? We don't. Okay, so let me write here. So real part of 1 upon z is basically 3 times of cos of natural log of 3. Simple. Fair? Easy. No worry about it. Any confusion? Okay, so we are stopping here, and the remaining questions like 8 to further, we will solve in the next lecture. If you have any confusion regarding that, you can write down in the chat box, and yes, I will definitely reply to that. And if you want to join the program and the revision program for the May 2025 exams, then yes, you can enroll. You can register yourself by scanning the QR code. I will mention the link in the description, and you can part of the MathsTribe, and yes, we will practice together in the group sessions. Okay, that's all for today. See you in the next video.